So in this video, we are going to discuss about the previous year problem on digital principle and computer organization. The first question is convert the above logical circuit into a NOR gate only. So this is a given circuit. You can see how the NOR gate will look like. So this is how the NOR gate will look like. Okay. So what is this? This is nothing but A plus B the whole part, right? So this is similar to that of if I apply a De Morgan's law, it will be look like this. Okay, so you can see this is nothing but A bar dot B bar, right? Because A, this is B, so you will get A bar B. So what I am going to tell is A plus B the whole bar is equal to A bar dot B bar. So you can see in the NOR gate I am having the bubble. This is called as bubble. Okay, bubble, the output at the output side, and at the for the AND gate you have the bubble at the input. Okay, at the both the input. Okay, so since I want to construct this one using a NOR gate, and if I want to construct an inverter, so the inverter will look like this, right? This is A and this is A bar. Okay, so this is my OR gate. If I short circuit these two point, okay, so now these two are A. This is not A, B. This is not B. Now this is A. Okay, so if I get so I will get A plus A the whole part. That is nothing but A part. So this is similar to that of uh, uh, so if I want to construct an AND gate, I can use this one. Okay. Now I'm going to construct the circuit, whole circuit using an OR gate. So and one more concept, you can see if I have a two and the NOT gate disconnected in series. So this is A, so this is A bar and this is A. Okay, so this is similar to that of this one. Okay, the straight line. Okay, so now you can see this is a OR gate and this is a AND gate. This is a OR gate and this is a AND gate. And if I want to construct it using a NOR gate, I have to insert NOT gate at the input side. Okay, so here I am going to insert two NOT gate for at this point. Okay, so similarly for C, I am going to insert two AND gate. So why I am inserting two AND gate means two NOT gate is similar to that of straight line. So this straight line, I am going to change it as to NOT gate, which is connected in series. Similarly for OR gate, at the output side, I have to insert a bubble, right, at the output side. So I am going to add two more NOT gate at the output side of the OR gate. So this is my A, this is my B, and this is my C, and this is my Q. Okay. So now you know this is an NOR gate, right? This is a NOR gate, and this is also a NOR gate, right? Since it is a bubble, this is also an NOR gate. This is also a NOR gate, and I can. So now I'm going to change this NOR gate, right? And this two NOT gate does nothing but a straight line. So I'm going to change it as a straight line. Now this is a NOR gate. This one. This is another NOR gate, and I have the circuit like this. Okay, A, B, C. Since I'm going to cancel these two, right? This is a NOT gate. This is a NOR gate. I'm going to cancel this one. This is a NOR gate, and this is an AND gate. Okay. Now I can replace this NOT gate by this one. Okay. From 2. Okay. So from 2, I can replace this NOT gate as like this. So this is my A and this is my B, right? And this is my C. And this is my another NOT gate. Okay. So this is how you have to plot the circuit for the using a NOR gate. So since this NOR and NAND gate is considered as a NAND and NOR is considered as a universal gate. So any gate can give, I can convert it into a NAND and NOR gate. Okay. So let me design another circuit. Okay. The question is F is equal to AB C bar plus DE plus AB bar D bar. Okay. So construct it using a NAND gate. So first let me draw this one. This is A, B and C bar. Okay. And this is D, right? And this is A, B bar, D bar. And I'm going to give it to OR gate, right? So now how the NAND gate will look like? This is my NAND gate, A dot B the whole bar. So this is similar to that of if I apply a De Morgan's law. This is nothing but AB. So A bar plus B bar. Okay. So for the NAND gate, I have to insert a bubble at the output side. For a OR gate, I am going to insert the bubble at the input side. Okay. And you know the formula, right? This is nothing but a straight line. This is A, this is also A. If I insert this one, this is also A. And if I want to make construct a NOT gate, okay, A bar. Again, if I short circuit this two, okay, A, I will get A dot A the whole bar, which is nothing but A bar. Okay. So now I'm going to insert two NOT gate at the inputs, the output side of the AND gate, right here. So this is A, B, C bar. Again, this one is D, E, and this one is A, B bar, D bar, right? And you can see I'm going to insert a two AND gate at the output, input side of the OR gate. Okay. So now this is my input side of the OR gate. So I'm going to add two NOT gate. Okay. So now we can see this is one more. This is called as NAND gate, and this is also a NAND gate. This is also a NAND gate, and this is also a NAND gate, right? So I can cancel these two NOT gate because it is a straight line, right? So now I can replace it like this. The same circuit, I can replace it as D, K, P, C bar, A B bar D bar. Hmm. So save NAND gate, right? So this is my See, if you want to convert this one in if I so if since it is uh, if you want to have a C bar here, can replace it by a NAND gate, right? So instead of this one, I can use like this, right? This is also a NAND gate if you want. Okay. So this was a previous year problem. I think this video is useful for you. Thank you very much.